In this video, we'll graph logarithmic function with base e, and we have translations, okay? Since we have base e, we cannot find exact values without a calculator, so we'll use a calculator to drawing this. First of all, let's see transformations. Because of -1 inside of the parentheses, the graph from the parent function is moved to right 1 unit, right? And then +3 after that, and that means the graph will go up 3 units. As we see, parent function of a logarithm function has vertical asymptote at x equals 0, right? If we move all the points to the right one, and vertical asymptote of this new function will be moved. Vertical asymptote is going to be at x equals 1. So we will graph vertical asymptote first. Always draw a vertical asymptote first before you complete the graph, okay? And now I need to use at least 3 points to complete the graph, but I have no idea. And even I plug the numbers because base is number e. Number e means irrational number. It is about 2.718, never ends, okay? And never repeats with any pattern. So we can't handle it. So let's use calculator for graphing this. So let me type this. What is the equation? ln x minus 1 plus 3. ln x minus what? 1 plus 3. Minus 1 plus 3. Okay. All right. Look at that. I open parentheses, so I need to delete that. I must check the number of the parentheses accurately. Okay, open for the input and then plus 3. Okay, that's it. So if I graph, my graph is dum-dum looking. Okay, oh, this is not right. And calculator TI-84 doesn't know what is doing. Okay, so I need to draw all the way to the down like that, right? So that is kind of a bug, and calculator is avoiding drawing a vertical part. So it is too steep and it just gave up, okay? It's not graphing all the way to the down. It just stopped. But we know vertical asymptote exists on logarithmic functions, so we will draw the vertical asymptote first and then we will follow that direction when we complete. Does it make sense? So we need to understand this is not correct drawing. So let's see. How can I get all the numbers for table? So second button, graph button, and I have numbers. Can I copy those? Okay, let me see. The numbers are, oh, disappeared. Where is it? Right here. Let me see. At 2, we have 3. I can't see it. Okay, let me move the calculator here. 1. Error. What does that mean, error? I don't write error in my table, and I need to say undefined. There is no number for that, undefined. Okay, undefined. Why? Because we have vertical asymptote. Okay, that's the vertical asymptote. And this is, ignore that line, okay? I used a different writing tool, and this is the overlapping of the graph on the thing, so I erase that. Okay. And 3, what is the point? 3.6931 on the calculator. 5, integer value, I have 4.09, wait a minute, am I copying right? 4.3863, right? Okay, so I have numbers, but how about 1.2 and 1.5? It's not there, so I'm going to evaluate it, okay? So let's use calculator. Second button, trace button, you can calculate the value. So hit enter for value, And let's use the number. What number? 1.2. And hit enter and you get y value here. It's right there. 1.390. 1.390. Okay, let's repeat one more time for 1.5. What were the buttons I need to calculate? Second button, trace button, and the first one is value. So you are using calculations above the trace button, okay? Hit enter and 1.5 and we have a value, 2.306. Let me copy it before I forget. I already forgot. 306. Okay. And now let's test this since I know how to use the values, okay? Second, trace, calculate, and first one, value. Can I pick a point very, very closer to this asymptote from the right? That is number 1, and let's pick a number higher than 1, but it is very, very closer. 1.00001. How about that? Okay, let's see. It says it's there, but the graph was not drawn, right? What's the number? Negative 8.5. So I convince you, okay, the drawing of this curve, it should go down, down, down. That's how you can check, okay? So don't trust this calculator when you graph logarithmic function. You need to understand the range of the logarithmic function is all real numbers, like inverse function, exponential function has domain or real numbers, okay? Flip, and then it should go down, down, down. But it is not showing all of them when you graph. So those are the numbers, and let's plot the points. 2 and 3, that is good point to plot. And 1, I'm not plotting. And 1.2, okay, that's too small, isn't it? Let me use 1.5, about 2 point something. All right, probably here. That's good enough. And 5 and 4.38, so about 4.4 right there. Connect the 3 points in a curve and the other end. Don't stop, just like your calculator, okay? Keep going forever and ever below. We are following that direction, okay? That is good graph. So show me 2 ends of the function with arrowheads and 3 points at least to complete the graph. Now let's talk about domain of this function. What is domain of this function? X values are greater than 1 because we have a right hand side, okay, from that asymptote. What is the range of this function? All real numbers. And when I introduce exponential functions, and I said domain is all real numbers, and now we say range is all real numbers on the inverse function of the exponential function, okay? So always range is all real numbers for logarithmic function. Make sense? Don't trust your calculator. Don't stop there, okay? It should keep going down, down, down. Now let's describe the end behavior. As x goes to infinity, my function h of x goes to infinity. That means up, up, up on the right end. Now let's describe the other end. As x goes to where? It's not going below than 1, right? So as x goes to 1, and y value h of x goes to down, 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 negative infinity. And if I introduce you again the calculus notation, we can describe the direction. X is approaching 1 from the right side, and we can put plus sign after that. Okay?